Unit 11, Waves. This is the schedule for up to May 5th of the class. We will have additional notes the rest of the week on May, the first week of May, and then probably the second week of May. The notes are going to be on sound waves. In class, you're going to be doing a Chapter 13.1 section review. Your homework is to review Chapter 13.1 and watch a screencast. You will be taking a quest at the start of the next class period, and I need your lesson plans by Monday, April 27th. The learning targets for this activity are: I can explain how sound waves are produced, I can relate frequency and pitch, I can compare the speed of sound in various media, and I can recognize the Doppler effect and determine the direction of the frequency shift when there is relative motion between the source and in the observer. Sound energy is a longitudinal wave. The sound travels in a spiral form like a slinky. Imagine what happens when you drop a stone in a pool of water. The water ripples wave out from the center of the dropped stone. The way waves move across the water is similar to how sound waves travel through the air. Parts of the ear. The ear is made up of an outer ear, the middle ear, and an inner ear. The part we see is the outer ear, which also includes the ear channel. The function of the outer ear is to capture sound energy and funnel it to the middle ear. The middle ear's job is to mechanically transform sound waves and send signals onto the inner ear, where auditory sensory cells are located. From the cochleas, sound information is then transferred to the auditory nerves and up to the brain. How does it work? The sound waves cause the eardrum to vibrate, which sends three tiny bones in the middle of the ear into motion. Motion of these bones cause the fluid in the inner ear or cochlea to vibrate. The vibrations of the inner ear fluid causes the hair cells in the cochlea to move. The hair cells change the movement into electrical impulses, and these are then transferred by the auditory nerve to the brain, and they are interpreted as sound. When you speak or shout, your vocal cords vibrate. These vibrations travel in a direction through the air as waves. When the waves reach our ears, they can make our eardrums vibrate as well, so we can hear the words. Sound waves travel on a medium, any solid, liquid, or gas. Sound travels by pushing the particles of a substance. The particles push into the particles next to them and then return to their original position. And the sound continues to travel in this form until it reaches your ear. Which state of substance would sound travel through faster, a solid, liquid, or a gas? Solid particles are closer together, so they'll be able to interact with other particles quicker than they're in the gas. Sound travels through solid faster than through a liquid, which is faster than through gas. Our ears are accustomed to hear the sound through the gases. In movies and on TV, you'll sometimes see and hear things explode in outer space, alien spacecrafts, and things like that. Is this really possible, knowing what you know about sound? Parts of a longitudinal wave. There are two major parts in a longitudinal wave: the compressions, which are an area of sound waves where the molecules are close together; rarefactions, this is the area of sound where molecules are further apart. The wavelength is the distance from an end of a compression to the end of the next compression. Frequency is the number of waves produced per second. Two other properties affect sound energy: the pitch and intensity. Pitch is directly related to the frequency of the sound. Intensity is directly related to the amplitude of the wavelength. The pitch is the rate at which vibrations are produced. The higher the frequency, the higher the pitch. Which picture above would have the lowest pitch? Which would have the highest pitch? Intensity depends on the strength or amplitude of the vibrations producing the sound. If a piano string is struck forcefully, the string swings back and forth in a wider arc. The stronger vibration then produces a louder tone, since stronger vibrations compress the molecules of the air more forcefully and give them more energy. which then is interpreted to our ears as louder sound. The Doppler effect can be observed for any type of wave, whether it's a water wave, sound wave, or light wave. Most familiar with the Doppler effect because of their experience with sound waves. For example, a police car or emergency vehicle was traveling towards you on the highway. As the car approached with the siren blasting, the pitch of the siren sounds are high. Suddenly, after the car passes you, the pitch of the siren sounds is very low. That was the Doppler effect, a change in frequency for a sound produced by a moving source. Mach numbers. Depending on temperature, sound travels around 750 miles per hour, which would be Mach 1. This is the speed. Twice this speed would be Mach 2, which is about the maximum speed of an F-22 Raptor. Speed Racer drives a car called Mach 5. That would imply that it goes 5 times faster than the speed of sound. Sonar is a device used for finding things that are underwater by using sound waves. The word itself comes from sound, navigation, and ranging. I've highlighted the correct letters in red. Ultrasound images are created by using a high-frequency sound wave which reflects off of body structures. Computer receives the waves and uses them to create a picture. Unlike an X-ray or a CAT scan, this test does not use radiation. It is done in the ultrasound or radiology department. The person lies down for the test. A handheld probe called a transducer is moved over the area being examined. You may need to change position so that the other areas can be examined. This is a 4-dimensional picture, so it is a movie of a baby inside a mother. Chart below lists the approximate sound levels of various sounds. The loudness of a given sound depends, of course, on the power of the source of the sound as well as the distance from the source. I want you to note that listening to loud music will gradually damage your hearing. The decibel scale goes from 0 to 180 on this scale. Constantly being exposed to decibels between 90 and 120 can lead to permanent hearing loss. Pain threshold is reached at 130. On July 15, 2009, in Ottawa, Canada, the band KISS achieved a decibel level of 136 decibels measured during their performance. After other stores complained about, or other neighbors complained about the noise level, the band was forced to lower their sound level. The So in Conclusion worksheet will also be available online. Fill it out so that you make sure that you understand what we've just covered. And finally, the homework is reviewing Chapter 13.1 and watch the screencast. You will be taking a quest at the start of the next class period. I need your lesson plans by Monday, April 27th for the following week.